This is one of the more important triangles you'll come up against. It just comes up over and over again. Now, I have what I call my unit 30, 60, 90 triangle. And in my unit, the length of the side opposite the smallest angle is 1. And that makes that square root of 3 and that 2. Now, if you want to add an x, that's fine. Notice that it doesn't change anything. What we're concerned with is the relationships of one side to another. That's what trig is all about. So I don't necessarily include the x. It makes it more complicated. Okay? So if this is my unit, and I tell you I have a triangle over here that's also a 30, 60, 90, but it has a hypotenuse of 6. What's this side over here?
It's 3.
What's the side down here?
3 root 3.
Yeah, because they're similar triangles, and so they're proportional. So this is the same, it's not the same, it's similar to this. Now, where the difficulties come in, what if I said this side is 4? Now what's x?
Well, wouldn't you have to divide by root 3 and then multiply by 2?
Correct, exactly. So, in other words, first we come up with the similarity ratio, which is that.
Mm-hmm.
And
then multiply by
right,
3.
Since this triangle here is the bigger triangle, then the hypotenuse is going to be bigger than 2. So we're going to multiply by 2, and we get 8 root 3, and then we're going to rationalize that. So we get 8 root 3 over 3. And that's what x...
So if you just did multiply root 3, like before
I multiplied by 2?
Say you go back to the short leg, so you divide by root 3.
Okay.
So then you do that whole, what you get the short side is.
Well, so the short side is 4 divided by root 3, because it's 4 divided by root 3 times 1. But that needs to be rationalized. And so that would be 4 root 3 over 3. You with me?
Yeah.
Okay.
And then can we go over how to get, like, if it's like 60 and you like rationalize, like take out whatever goes into 60, like, I don't know, like square root.
Not sure what you're asking. Rationalization doesn't change the number. In other words, when I say 1 over root 3, that's exactly the same numbers I get after I rationalize. The only reason math does not like that is they don't like dividing by an irrational number or an imaginary number. It doesn't make sense if you think about what division means. So they never give an answer with an irrational denominator. They always rationalize it, and it comes out to be that.
Well, okay, maybe I explained that wrong. Then if I have root 52,
okay,
and the answer ends up being, I don't know,
okay,
like what this...
So we're simplifying.
Simplifying.
Okay, so when we simplify a radical number, what we're doing is trying to split it up into 2 factors, one of which is a perfect square. 52 factors into 4 times 13. And 4 is a perfect square. So this becomes 2 root 13. Does that answer your question?
Yeah.
Okay. Now, before we go on, let me make sure that we're clear. What does this become?
Still root 10 because
Correct. In other words, the only factors are 5 and 2, and neither of those is a perfect square, so we don't do it. That's more complicated than what we started with. So you only simplify it if you can pull an integer out of it.
Okay.
Okay. Now, you said there were some of these problems you wanted to ask me about?
Yeah, let me get one.
Or have you sent me any more? Or is this it so far?
Well, I have another one, but that's circles, and I'm fine at circles. Okay, I got 14 wrong. I don't know.
Okay.
I guess just do it and...
Let's look at 14. I actually had some questions about 14 myself. Now, for them to call 14 a trapezoidal pyramid, I think requires that that point be over the center of the base, which is a trapezoid.
I just found my mistake.
You good to go on? In other words, what's the general formula? What is the volume equal to? 14.
Base times height divided by 3.
Capital base times height divided by 3. And it's important that you say capital because there's a big difference between this capital B and the B that I get when I have base times height in a rectangle. That is a linear dimension. This is an area dimension. So that's the difference between the capital B and the little b. So if we apply this formula to that trapezoid, the only thing we need is the area of the base, right? Well, that's the area of a trapezoid. What's the formula for area of a trapezoid?
Base 1 plus base 2 times height divided by 2.
And in this problem, they give us base 1 is 15. The base 2 is B. Height is 8 of the trapezoid. The height is 8. Also, do not get confused between those two h's. They are not the same. The h in the bottom is this vertical height of a trapezoid. The h on top is the height of the pyramid. Okay, you with me? So the way we're going to solve this is the height, this is the base capital B that we're talking about. And they give us the volume. The volume is 1776. So 1776 equals capital B times h divided by 3, and this h is 36, this h is 8. So it really should be like an h sub 1 and an h sub 2. That's going to be the most confusing part about these kind of problems, is your h's are different. Not only are the b's different, but the h's are different, and really they probably should use a capital H just to differentiate it, but nobody does. And the reason they don't is because this h is a linear measurement and this h is a linear measurement, as opposed to the b's. The b's are different. So if I know one of the bases and I know both heights, the only missing variable here is the b. So let's fill in everything we know. We know one of those bases is 15. We know one of the heights is 8, and the other height is 36. Now there's only one variable in that equation. It's b. And that's what you're trying to solve for. That's what every one of these problems comes down to, is writing a formula and ending up with only one variable. And then being able to solve for it. Any other problems on here?
20. Did I take a picture of 20?
It's not. Oh, yes, it is. Excuse me. It didn't go down far enough. It is on there. Yeah, let's take a look. I haven't looked at it yet.
These are like density ones, but I totally forgot how to set these up.
Right.
I know it's mass over volume, but...
All right. If you don't know how to do these, sometimes it helps to draw a picture. There's our container, our cube. Okay, it's 42 meters on a side. When we stick this irregularly shaped object in it, it causes it to rise by 11 centimeters. What's the volume of that object? In other words, the water level was at here, and that water level goes up by 11 centimeters.
So would it be... Can't you just do 42 plus 42 plus 42?
Not plus.
Or times, I mean.
Well, that would give you the volume of the cube.
Oh.
That's not what you want. You want the volume of the irregularly shaped object that you placed in the water. And that is the same volume as the amount of water that is displaced. So there's the water level before we put it in. Here's the water level after we put it in. What's the volume of that water level increase?
11 centimeters.
What's the number? How much is the volume of the water that's not displaced? What's the volume of it?
So would you do 42 times 42 times 11?
Yeah, exactly. In other words, it's the volume of that space, right? If I said, what's the volume of a rectangle full of water that's 42 by 42 and 11 inches deep, you would say 42 by 42 by 11. So that's the volume of the irregularly shaped object. Do you have a calculator? What's that number?
42 times 42, 11. 19,404.
What is it?
19,404.
And what's its units?
Wait, the density?
No, we're not there yet. What's the unit? Is it cubic centimeters? Is it cubic inches?
Cubes.
It's centimeters cubed, right? Right? Okay. Now, if we want to find the density of the object, it weighs 3,000 grams. So, density is usually in weight per cubic something. So my answer I want to be in grams per cubic inches. Well, in order to get that, I got to divide 3,000 grams, which is what the thing weighs, by the volume of it, which was 19,404 cubic centimeters. And you will find that that number is 0.15 grams per cubic centimeter. So the only real question on how to do 20 is whether your answer is going to be cubic centimeters per gram or grams per cubic centimeter. And if you think about density, you want weight per volume. That's what determines density. The reason gold is denser than lead is because a cubic centimeter of each, the gold weighs more than the lead does. So its weight per cubic centimeter is higher. So that's what density means, is the weight divided by the volume. And that's how you know to divide 3,000 by 19,404.
Okay.
We'll do 19.
Yeah.
Now here, they don't want the density, they want the volume. It's in a cylindrical container.
So do I have to find the circumference?
No.
Or the area?
Hold on. Here's our cylindrical container. Right now, the height of the water is 24 centimeters. When you drop this irregularly shaped object into it, and the radius is 16, when you drop the irregularly shaped object into it, it causes it to rise by 3.5 centimeters. So the new level goes to there, and this is 3.5. So what's the volume increase? What is this volume of water right there? And that's the volume that the object has.
So 3.5 times 24 times whatever the...
No, the 24 actually doesn't come into it. What's the volume of a cylinder? What's the general equation for the volume of a cylinder?
Base times height.
Capital base times height, which translates for a cylinder into what? What's the capital base equal to?
Pi r squared.
Times height, okay?
Yeah.
Well, r is 16.
Well, r is not, it's 8.
Did I read it wrong? Has a radius of 16.
I thought the diameter was 16.
No, the radius is 16. Question is, what is h?
Well, if we do multiply 16 squared times 3.14, and then...
But what is h? H is 3.5.
Why is h 3.5?
Because that's the height that it caused the water to raise. In other words, the volume of the object is the same as the volume of that water. Well, notice that that water is its own cylinder. It's a cylinder that's 3.5 centimeters high and has a radius of 16. So this 24 is completely irrelevant. We do not need it. The hard way to do this problem would calculate the volume based on 24 and then calculate the volume based on 27.5 height, subtract the two, and that would give you the volume of the shaded region. But there's no need to do it the hard way. We can figure out the volume of that shaded region by just taking the volume of that cylinder, which has a height of 3.5 and a radius of 16. And so that is the volume of the object. And that's what they're asking for, so that's all you need to do. Why they gave you 24 centimeters, I guess, was to just kind of throw you off.
Okay.
And using 3.14 instead of pi, that's just the teacher doing that. She could have left out that last sentence and it would have been a better problem. In other words, your answer should be in terms of pi. Whatever this number is your answer. No need to approximate it by using pi equal 3.14. Every one of these problems, I used your first page with another student yesterday, and I realized that everybody knows how to do it if you know the general formula. If you don't know the general formula, you're lost. You have no way to do any of these. So make sure you know the general formula, all general formulas. In other words, volume of a sphere, volume of a cone, volume of a prism, volume of a cylinder, volume of a rectangular solid. Make sure you know all of those volumes, and then it really becomes just a question of filling in the missing numbers. Now, obviously, volume of a prism is capital B times H, and that can get a little complicated if the base happens to be a trapezoid where they have another H involved also, and they're not the same H's. So you have to be a little careful, but that's probably the only problem that's going to give you that situation. Number 11, how many sides are there in that shape?
Seven.
Yeah. We had a problem like that once before, and it was hard to tell, but they gave us the perimeter, and we didn't need to know. But in this case, we really do need to know, because to get capital B, which is the area of this septagon, you have to do 1/2 the apothem, which is 14.5, times the side length, which is 14, times the number of sides, which is 7, times the height, all divided by 3. But you definitely need to be able to count how many sides there are in this figure. But you can do that. They show them all. You had one once that you couldn't actually figure it out properly. But you didn't need to because they gave you the perimeter. If you have the perimeter, then you don't need the number of sides or the side length. All right, Quade, you good to go until tomorrow?
Yep, all good.
Okay, I'll talk to you then.
Alright, thank you.
Bye-bye.